Hi there, Year 9, it's Mr. Smith here, and I've got a special lesson for you guys on something called the Fibonacci sequence, and we'll talk about how that relates to something called the golden ratio. Now, a lot of you have probably heard of this sequence, the Fibonacci sequence, and some of you probably even know what it is and how we come across it. But let's review for those who this might be a bit new for. The Fibonacci sequence was developed by an Italian mathematician named Fibonacci, but he was not the first person to recognize this. But, however, we'll show how this sequence goes. Now, all it is taking, you've been dealing with linear sequences and quadratic sequences, and you know that in a linear sequence you might have something that goes like 1, 3, 5, 7, 9. Every time it keeps increasing by 2. And a quadratic sequence keeps increasing by, it'll have a squared number in it, and we might be adding additional things or taking additional things from that to have that sequence. But a Fibonacci sequence is a specific sequence. There is a formula we could set up for it, but it's not really possible to try to figure out maybe what the 1000th term is of the Fibonacci sequence. It's rather difficult. But let's just break it down basically what we are. Okay, so if we start with the number 1, what the Fibonacci sequence says is that the next number that follows this 1 is the sum of the two numbers before it. So whatever this number here is going to be, I need to add the two numbers before it. Well, I only have the number 1, and then I have nothing before it. So 1 plus nothing is 1. The third term of the sequence is, again, adding the two numbers before it. This time I have two numbers. 1 plus 1 is 2. The fourth number is going to be the two numbers before it. So 1 plus 2 is 3. And then this one is going to be 5. This one's going to be 8. That one's going to be 13. Now, mathematically, if you were to come across a question, maybe on a quiz or a test or something, it might say, what's the first number after 200 in the Fibonacci sequence? And you might think, aha, I remember from my linear sequences that I could create an nth term. That's not really possible with the Fibonacci. You actually do have to kind of write this out. So let's take this. Let's say, what is the first number after 200? And I'll have to just keep going on up to see what it's going to be. So 8 plus 13, 21. 21 plus 13, 34. 34 plus 21, 55. 55 plus 34 is 59, plus 3 is 89. 89 plus 55 is going to be 144. And then 144 plus 89, 56, 23, I believe gives me 233. So at this point, I can see that 233 is going to be the next number, is the first number after 200 in my Fibonacci sequence. Okay, so what's the big deal about this? Why does the Fibonacci sequence exist? What's the point of it? Well, you might find out in nature and all kinds of real-life applications, the Fibonacci sequence you come across every single day, and you don't even realize it. For example, petals on flowers. Virtually every single flower that is out there, not all, but most flowers out there, the number of petals when they have their full petals are a number in the Fibonacci sequence. For example, we see this one here. I've got 1, 2, 3, 4, 5, 6, 7, 8. This one here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm not going to keep counting for the rest, but even down to here, that has one petal. All of those flowers have petals that are in the Fibonacci sequence. Trees, plants, bushes, they tend to grow with their branches in a Fibonacci sequence, and how the leaves come out of those branches as well. And here we have some examples of that. We can take a look at how a tree might grow. That we have one main trunk that's coming out, and then it splits into two. and we're talking about this one down here, the lower left. It splits into two, and then from there those two will split into 3 branches, 5 branches, 8 branches, and 13 branches, and it keeps going on like that for quite a while. The Fibonacci sequence also happens to come up in seeds of flowers. Again, not all, but many. And they tend to form spirals within this. A lot of you who are into art may have seen Fibonacci sequences in art. Again, a lot of spiraling techniques are used using the Fibonacci sequence. And again, the number of seeds or the number of spirals that happen to be in there will be a reflection again of that Fibonacci sequence. You can also see the Fibonacci sequence in fruits, pineapples, bananas. If you ever, next time you cut a banana, you will notice that it'll either have 3 flat edges or 5 flat edges. Now, the reason that this plays a role, what the Fibonacci sequence is, it develops into something, again, a bit more, just sorry about this, a few more examples of spiraling techniques using the Fibonacci sequence. That's your basic model and how this transposes into different things in the real world. Even things like hurricanes follow the Fibonacci sequence with the spiraling that they have. But where this develops into real life, even more so, is something called the golden ratio. Now, the golden ratio is a special number. It's represented by the Greek letter phi, and to approximate it, the golden ratio is approximately 1.6180339, and that's rounded. That keeps on going actually forever and ever and ever. And what this means is that, for example, if you had a measurement of 1.6188 centimeters, for example, the ratio of something next to it or in relation to it would only be 1 centimeter. And let me demonstrate where the Fibonacci sequence comes into this. So again, rewriting this, get 8, 13, 21, 34, 55, keeps going on. These numbers get close in the Fibonacci sequence, get closer and closer and closer to that golden ratio number of 1.6188339. And how that's done is this second number, 1 divided by 1 is 1. 1 divided by 1 is 1. 2 to 1, the ratio of 2 to 1 is 1.5. The ratio of 3 to 2 is 1.66. The ratio of 5 to 3 is 1.6. And these, as you keep finding this ratio of 8 to 5, 13 to 8, 21 to 13, 34 to 21, 55 to 34, keep getting closer and closer to this number of 1.6188339. So where does this work in the real world? The human face. You notice how these lines keep flashing up. I've lined up 5 women across here, and you notice that how I have a line going across their eyes, the bottom of their nose, across the middle of their mouths, and the bottom of their chins. Virtually every human face is in this golden ratio. In other words, the ratio of the eyes to the bottom of the nose is 1.6 times bigger than the ratio of from the bottom of the nose to the middle of the lips. And that's how this kind of thing works. So let's explore some further areas where this golden ratio comes in. Now, the golden ratio can be used in art, mathematics, geometry, beauty, design, theology, cosmology, music, and all around life. And I want to show you where a lot of this comes in. Now, A lot of people have theorized why the golden ratio works as it does. A lot of it does have to do with some physical limitations. For example, plants, when the branches of plants grow, or they tend to grow out like this, and then they go out in angles. And what we're talking about here is as the branches grow, they tend to grow in an angle of 222.5 degrees. This is an optimal angle for branches to grow. But that 222.5 degrees of a 360 degree circle is in that golden ratio number of basically 1.62. So 360 degrees is 1.62 times bigger than 222.5 degrees. But people, especially in art and design and these kind of things, have applied the golden ratio. People just find this aesthetically pleasing. If you can take a look, we've got we're talking about how this design of this car has been set up, how the headlights appear, where they appear on the front of the car in relation to the grille that's on the front and the grille that's on the bottom of the car, as opposed to the measurements of the windscreen. It's aesthetically pleasing. Postage stamps, how these stamps have been drawn out. Art composition. The most successful animators are the ones who maybe knowingly or unknowingly use the golden ratio when they're creating characters. They're more pleasing to the eye. They're using the golden ratio in that composition, in the art composition of their animation. The golden ratio was used thousands of years ago by the Egyptians within the pyramids. In the way that they have structured, the way they built, aerial shots have shown that pyramids, like for example the large pyramid of Giza compared to a smaller pyramid, its placement and structure works as part of this golden ratio, the 1.62. There have been written records that the golden ratio was first talked about by a Greek guy by the name of Euclid in 300 BC. And it's come all the way up and is still used today. For example, many of you may have seen the movie or read the book The Da Vinci Code by Dan Brown. It's talked about extensively. It's used in product marketing, in brands. Here's an example of the Toyota brand. Again, set up with the golden ratio. Pepsi bottles, Mountain Dew bottles, virtually every bottle you see of soda today is based, the design and creation of it is based on the golden ratio. And maybe the most famous brand of all, Google. The design of the Google logo has been designed around this golden ratio. It's also used in business. Now what's going on here is that stock market analysis via the Fibonacci sequence. So what we're talking about here is that human expectations, they occur in a ratio that approaches this golden ratio. Changes in stock prices largely reflect human opinions, valuations, and expectations. There's been a study done by a mathematical psychologist, and he demonstrated that humans exhibit positive and negative evaluations of the opinions they hold in a ratio that approaches that golden ratio number, with about 61.8% positive and 38.2% negative. So phi, which is that golden ratio, and Fibonacci numbers are used to predict stocks. For example, that 1.618, the gold mean, and the numbers of the Fibonacci series, they've been used with great success to analyze and predict stock market moves, and these are known specifically within that as retracements. Going back to that one I had with the photos up there, photography is taught that the best photos that are taken are used with the golden ratio. People who have a grasp of knowing what to look for when they talk about that photographer's eye, unknowingly, that person is using the golden ratio. Filters that are used in your photo apps, such as Instagram or Snapchat or whatever you may use, those have been developed, ratios within those apps have been developed using that golden ratio of the 1.62, again to make it more aesthetically pleasing. Okay, I've hoped you enjoyed this little video. In the meantime, we're going to be putting up a couple of activities in the continuity folder for you guys based on this. We're going to have you doing a little Sudoku quiz and maybe a little extension challenge, but take a look for it up there. In the meantime, stay safe and hopefully see you all soon.